Welcome back to Lord Gizmo. In today's video, Du Doan walks us through the step-by-step build of the Avatar SA-2 Samson helicopter replica. This helicopter model appeared in the film Avatar as part of the movie's futuristic aircraft lineup. To form the base structure, he starts with styrofoam, which will later be strengthened using additional support materials. He carefully outlines the components on the foam, cuts them to shape, and assembles them piece by piece. A spray adhesive is used to securely bond the foam sections, ensuring they stay firmly attached during shaping and reinforcement. High-density styrofoam is a common choice among DIY builders due to its ease of shaping and ability to hold fine details. This section forms the front of the fuselage, where he constructs the helicopter's cockpit. He then moves on to welding metal components to create the internal frame of the fuselage. Next, he trims out the center area to make space for the cockpit interior. By combining internal metal supports and piping with the foam structure, he improves its strength while maintaining the signature look of the Avatar helicopter. Using this approach, he continues shaping the full fuselage, paying extra attention to the nose section, which features complex aerodynamic curves. To cut the foam accurately, he uses a range of sharp tools, like a machete, hot wire cutter, and a fine blade. He makes a series of partial cuts, also known as notches, along square metal pipes. This allows him to bend them cleanly into shape before welding them together to form the helicopter's landing skid. Next, he carefully carves channels so the support materials fit perfectly and stay level with the surface, creating a smooth finish. He's now cutting and shaping foam blocks to build the landing gear. Each piece is trimmed and smoothed to match the curve of the helicopter's skid. The nose of the Avatar SA-2 is one of its most recognizable parts. He plans to add fine details to capture its signature look accurately. The smooth curved shape must transition cleanly into the cockpit's wide window and align with the helicopter's aerodynamic body. This step is challenging as he's shaping the nose taper, one of the helicopter's most distinctive features. It gives the aircraft its science fiction, military-style appearance. Functionally, the taper improves aerodynamics by reducing drag and helping airflow smoothly over the fuselage during forward motion. Getting it right requires careful detailing and precise craftsmanship. This styrofoam block will form the upper canopy of the helicopter. To refine the window openings, he makes additional cuts and adjustments, using carving tools to carefully shape each section. Smoothing the surface ensures the doors will open and close without obstruction. He's now adding hinges, giving the doors a functional military-style look when opened. The upper part of the SA-2 Samson includes several aerodynamic features, resembling small stabilizing fins like those on a fish. These round structures will act as exhaust outlets for releasing engine gases. The marked areas indicate he'll return later for detailing. He begins cutting the rear section to slightly extend the helicopter's length. He also removes panels on both sides to install sliding doors, but first, he'll focus on completing the tail. The goal is to make it smoothly rounded, matching the original design, which requires careful surface finishing. This stage demands precise cutting and careful placement to ensure each part fits exactly where it belongs. Once the tail section is shaped, he detaches it from the main structure. This gives him better access for detailed adjustments. With the tail now reattached, he adds more styrofoam and begins wire cutting. Using low voltage, the heated wire slices smoothly through the foam for clean shaping. The tail structure must maintain lateral stability to help balance the helicopter during flight. When the main rotor spins, it creates powerful rotational forces. Tail fins help counteract that force and keep the helicopter stable. Dudone begins crafting these fins using his usual hands-on method. As he shapes the fins, he adds internal contours to hold wiring and mechanical components, ensuring the fins are both functional and realistic. It's impressive how much can be built using mostly styrofoam as the primary material. Now, he removes the front section to refine its shape, aligning it more closely with the original design envisioned by James Cameron. The alignment must match the rest of the body perfectly. Next, he starts work on the rotors. To shape them, he builds a rotating wire cutter that allows him to carve styrofoam into precise circular forms. Multiple curved foam pieces are cut, aligned along a marked circle, and then joined. He carefully trims excess foam to ensure even thickness throughout. After marking key areas, he chisels out sections by hand. This method lets him create smooth, rounded guards around the propellers, similar to the design used on quadcopters. He now focuses on the propeller blades. These must be capable of generating enough lift to support the helicopter. Powerful motors will be installed at the center to spin the blades at high speed. Once again, he uses styrofoam to build the rotor housing, modeling it after the SA-2 Samson. After shaping and smoothing, the result is both clean and accurate. He begins cutting an opening in the rotor housing to fit the rotor blades securely. Before mounting them, he reinforces the blades with fiberglass and epoxy to improve their strength and durability. The blades are then shaped to fit precisely into the rotor housing. He also strengthens the rotor coupling using fiberglass for added support. Screws are fastened into place, and colored tape is applied, black for the lower side, blue for the upper, acting as a visual guide. With everything ready, he attaches the rotor assembly to the main structure. Both the rotor and housing components appear to function smoothly. He cuts and shapes a thin, curved styrofoam panel to cover the exposed metal structure supporting the rotor. Now he turns to the tilt rotor wing, beginning the detailing work. This feature gives the helicopter a distinctly military look. He completes the integration of the tilt rotor wings and adds a top cover to finish off the design. A custom housing is built to conceal the tilt mechanism beneath the wing. The roof structure grows larger as he adds exhaust outlets, an important addition if an engine were to be installed to guide gases outward. With the rotor system in place, Do-Doan smooths the body surface to give it a clean, uniform finish. At this point, you might wonder if the body is too fragile, and you'd be right. That's why he's reinforcing it with a steel skeleton. He cuts out the floor section to build a base frame, similar to a railing. This provides flexibility to add more structural components by welding them directly to the base. By positioning the metal rods where stress is most likely to occur, he strengthens the structure efficiently. The framework is made of long aluminum rods running the full length of the fuselage, creating a solid internal backbone. After building the frame, he lines the interior with high-density styrofoam, including the flooring. Next, he moves on to the pilot seats. These are designed to reflect the helicopter shown in the Avatar film, built to be both sturdy and visually accurate. To support the seats internally, he constructs a framework and installs it inside, ensuring nothing is visible from the outside. All 4 seats are now ready for placement, 2 in the front and 2 in the rear. With the seating complete, he begins assembling the landing gear. Long aluminum pipes are cut and bent to match the shape of the skids. He welds, grinds, and connects multiple parts to finalize the landing skids. These will be attached to the reinforced base created earlier. Wheels are added so the helicopter can be moved easily while on the ground. He removes the tail section again to make critical adjustments. This part is essential for maintaining directional control during flight. The tail is rebuilt using the same aluminum frame structure used in the rest of the helicopter. Once the frame is complete, it's covered with high-density styrofoam to maintain a consistent aerodynamic profile. A streamlined tail helps reduce turbulence and allows smoother movement through the air. The structural frame extends into the tail fins. Inside the vertical stabilizer, long aluminum rods are embedded, providing stiffness and preventing flex under flight loads. With major components completed, he now begins reassembling the helicopter to check how everything fits and functions. Unexpectedly, he disassembles it again, but this time to prepare for a major visual transformation. He applies a custom mixture of milk glue, cement, and paint to the surface. This not only gives the helicopter a distinctive gray tone, but also prepares the surface for fiberglass application. Next, he lays out sheets of fiberglass, cuts them to size, and begins reinforcing both the interior and exterior with epoxy. Once soaked and set, the fiberglass hardens, adding significant strength to the entire bill. He also applies carbon fiber to select areas for a smoother, more seamless finish. After fiberglassing, he trims the excess material cleanly along the edges and smooths down the surfaces using a saw. Rinsing with water helps wash away any remaining dust and debris. Now that the body is prepped, he reinstalls all the components. Dudone climbs inside to test the cockpit layout and seating comfort. The helicopter is beginning to look complete. A coat of yellow paint is added, with red accents to bring out more contrast and visual appeal. The build even includes replica missile launchers for visual accuracy. Doan plans to add more features soon, including a working steering system and even a music player for a more interactive cockpit experience. Follow his channel to see the full step-by-step journey behind this build. That wraps up today's video. Don't forget to like, share, and subscribe. We'll see you in the next one.